Hello everyone, this is the first lesson recording for IM1, May 18th, 2021. So I want you to start by looking at your notes from last class. Type in chat, what are the 4 shortcut rules that can be used for triangle congruence? We learned 4 of them. Can you name them all? Okay, in private chat, please try to name 4 shortcut rules. Start with some announcement. The tessellation project is due today at 11:59 p.m. Okay, so make sure it is done. Make sure it is turned in on time so that you do not incur any late penalty. Remember that I am looking for design plus a written reflection. So you need to see the rubrics for it. Next class we'll have a quiz number 6. It's on geometry symbols, triangle sum, and triangle congruence. So you need to be very comfortable with homework number 27 and homework number 30. And that is today's homework. But I'll try to grade them quickly enough so that you will get some feedback before the unit test so that you understand whether you're doing things correctly or not. There are only 4 classes left and plus the final. Okay, so, and if we were to go to the final schedule, this is what the spring final exam schedule is like. The Monday before the final week is a Memorial Day weekend, so it's a long weekend, so there's no school. But then on Tuesday, Wednesday, and Thursday are your finals. For period 4, you're going to have your final on Wednesday from 9 to 11. For period 5, Thursday 9 to 11, and then for period 6, 12 to 2 on Thursday. And then you're done. You're done for the year. All right, so let's get to our lesson. So triangle congruence rule. As you have told me, they are SSS, SAS, ASA, and AAS. Okay, what does SSS mean? That means we have all 3 pairs of corresponding sides that are congruent. What about SAS? Well, that means we have 2 pairs of corresponding sides. Okay, S and S tells me there are 2 pairs of corresponding sides, plus the included angle. Notice that the angle is squished between those 2 sides here, first side and the second side. So it's the included angle are congruent. ASA means 2 pairs of corresponding angles. That's why you have 2 of the A letters, and the included side are congruent. Okay, so the side that is congruent, the corresponding side pair that is congruent is squished between the 2 angles that are congruent, 2 angle pairs that are congruent. What about angle side? We have this 2 pairs of angles as well, just like ASA, but this time the angles are next to each other, and then the side pair that is congruent, it is not the included angle, but it is excluded side of the 2 angles that are congruent. Okay, so you're going to do some practice on using these rules. So you're going to be working on the Desmos. So please start, and you're going to be working on card number 1 to 16. Okay, here we go. Which triangle is different to the others? Okay, so if I look at this, I have 6, 4.5, and 25 degrees, 6, 4.5, and 25 degrees, and 6, 4.5, and 25 degrees. Okay, so I have the same measurements, but which one's different? Okay, if I say this is different, I am going to try again. Why is that? Because I have 6 and 4.5 and 25 degrees that is congruent is the included pair, included angle. Okay, so we're looking for the included angle. In this case, the 25 degrees is not between 6 and 4.5. So this is actually the different one. While at 6 and 4.5, 25 degree is in between the 2 sides that are congruent. Okay, so which is the test that shows the other two are congruent? Okay, so I'm looking at these two. Which is the rule that I can use? Okay, so I have side here, 4.5 and 4.5, and another pair of sides, 6 and 6, and the angle pair that is congruent is in between. It's squished between the two sides that are congruent. So it's going to be angle, side, angle. All right, then which congruence rule would you use to prove that the triangles are congruent? Okay, so looking at this, what would you use? We have side here, then we have another pair of side, and we have the angle in between the two pairs of sides that are congruent, so it's going to be side, angle, side. What about this? Okay, so 80 degrees is referred to this arc, which is the angle measured. 50 degrees is referring to this angle. 3 centimeters is referring to this length. So we have 3 centimeters, then 80 and 50, 3 centimeters, 80 and 50. So it is, we have a side and two pairs of angles, but the side that we're dealing with is not the included. It's not this side in between these two angles, but it's outside of those two angles. So it's going to be angle, angle, side. All right, what do we have here? 4 centimeters, 4 centimeters, 1 centimeter, 1 centimeters, 3 centimeters, 3 centimeters. 4 centimeters referring to the length. 1 centimeter is referring to this side length. And 3 centimeters referring to this side length. So this is side, side, side. Okay, what about this? Which congruence rule? Okay, hint, separate the left and the right triangle. If I was to redraw this with the left and the right triangle, I could separate the left and right triangle like so. Okay, so the left triangle will look like this, will be this one. Okay, what are the dimensions? I know that this is 80 degrees. Okay, and this angle is 10 degrees. What about this length? This length is 5 centimeters. So we know that this is 5 centimeters. Okay, what if, let me use another color. What if I use this as the right triangle? Okay, let me draw over now. What do we know about this angle here? That's 80 degrees. Okay, and what about the bottom angle? That's 10 degrees. Then we have a shared side that is going to be 5 centimeters as well. Okay, so 5 centimeters, 5 centimeters. Obviously, we're talking about the same line. Okay, this is what we call common side. It's being shared by both the left triangle and the right triangle. And when you talk about comparing the left triangle to the right triangle, we have a side here. We have an angle here, angle pair, and we have another angle pair. But the side that is congruent is not in between. It's not the included. If it was in between the 80 degrees and 10 degrees, if it was this side, that will be angle, side, angle. However, because this is outside of that, this is going to be angle, angle, side. This is the angle, angle, side. So I am going to click on angle, angle, side. All right, then mark the angles or sides which must be congruent to prove the triangles are congruent by angle, angle, side. Okay, so I have angle L and angle S corresponding, angle N and angle R corresponding. So I have one pair of angle, another pair of angle, but the side that is congruent cannot be the included. It cannot be this one. It can be this one, so I could put a tick mark here and tick mark here. Or alternatively, I could have done a tick mark here as well, because that would mean angle, angle, side. Okay, so depending on which direction, I could have chosen this side to be congruent or this side to be congruent. What about this? Same thing. I could have chosen this side to be congruent, these two pairs to be congruent, or I could have chosen these two sides to be congruent. Oh, no, that would be included. That would not be correct. I could have chosen this side to be congruent to each other. Okay, because then you would have angle, angle, and side. And the side that is congruent is not in between. It's not the included side between the two congruent pairs of the triangle. Two congruent angle pairs of the triangle. All right, so mark the angle sides that must be congruent in order to prove the triangle congruence. The triangle is congruent by side, side, side. So I have one side, two side, and so I need the third side. Okay, and on one side, two, and 1, 2, 3. So I have all three sides, side, 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 that are congruent. All right, now state the additional information that would need to be shown in the diagram to prove the triangles are congruent by ASA. If I want ASA, that means I want the sides that are congruent to be in between the two pairs of angles that are congruent. So I have one pair that corresponds to this pair, and another pair of congruent angles are this. So I want the side to be in between those two. So I need this side to be congruent to this side. So which is that? Which one is that? Well, that is, how would you call this side? It starts off in D and ends in E. Or you could say E ending with D. So either DE or ED is going to be congruent to KLJ or JK. So I have DE here and KL. I don't want DE and JL. JL would be this one. Okay, so I want DE and JK. So it's this one. Okay, so now that I know that these two triangles are congruent by ASA, I need to write the congruence statement below. Okay, so D, E, F. D corresponds with J, so that J has to be the first letter. And E has two arcs, K has two arcs, so that's going to be 2K. And then finally, it will be the last letter, L. That will be my triangle congruence statement. All right, then state the additional information that would be needed to prove by angle, angle, side. Okay, so I need angle, angle, side. So I have one angle here. I need another pair of angle. If I put the congruent angle pair to be here, what would this be? This will be angle, angle, and side in between. So it will be angle, side, angle, and angle, side, angle. We don't want that. We want angle, angle, side. So this will not do. So we need the angle to be somewhere else. Where? It could be here. If that is the case, then we have two pairs of angles and the side that is not included, not this one, but it is outside of the included angle. There are two pairs of angles with an angle that is outside. So what is this angle? It's going to be angle K is congruent to angle U. So which one says angle K is congruent to angle U? It's this one. Oops. And then complete the triangle congruence statement below. Okay, so I need to write the MKL. Where